In this video, we will look at expansion involving linear expression. The focus will be on expansion of a constant or a variable with a linear expression. Expansion of two linear expressions and of three linear expressions. And expansion of common linear expressions. We start with the expansion of a constant or a variable with a linear expression. To expand, multiply the variable or constant with every single term in the linear expression. Looking at the example, it is an expansion of a constant, 3, with a linear expression, x plus 2. The constant, 3, has to multiply by x and multiply by 2. After simplifying, the result of the expansion is 3x plus 6. The next example is an expansion of a variable, y, with a linear expression, x plus y. Similar to the previous example, the variable, y, has to multiply by x, and multiply by y. After simplifying, the expansion results in xy, plus y square. For a linear expression with more than two terms, the same idea applies. The variable or constant has to multiply every term in the linear expression. In the expansion of -2 in the linear expression x minus y minus 6. The constant, -2, has to multiply by x, multiply by -y and multiply by -6. Be mindful of the sign of the terms. After simplifying, the result of the expansion is -2x, plus 2y, plus 12. The next expansion involves the variable, b, and the linear expression, a, minus 4, plus 4b. By multiplying the variable, b, with every term in the linear expression, the result is ab, minus 4b, plus 4b square. In the next segment, we will look at the expansion of two linear expressions followed by the expansion of three linear expressions. For the expansion of two linear expressions, each with two terms. For the expansion of two linear expressions, we can use a multiplication frame or by multiplying all the terms in the first linear expression with the second linear expression. Starting with the multiplication frame, draw the frame as shown, and write the multiplication sign on the top left. Fill up the first column with the first linear expression. Then fill up the first row with the second linear expression. Carry out the multiplication and fill up the corresponding boxes as shown. Sum up the results from the multiplications and simplify where possible. The next approach is to multiply all the terms in first linear expression to the second linear expression as shown. Expand each of the term and simplify where possible. Let's look at an example, x minus 7, multiply by x plus 2, using each of the methods. To use the multiplication frame, start by drawing the frame. Write x and -7 in the first column. Then write x and 2 in the first row. Carry out the multiplication and fill in the corresponding boxes. Add up the results of the multiplication and simplify where possible. The second method is to multiply every term in the first linear expression by the second linear expression. In this example, we have x multiplied by x plus 2, plus, negative 7 multiplied by x plus 2. Expand and simplify where possible. The following example has a linear expression with 3 terms. To use the multiplication frame, add one more column to accommodate the extra term. In the last part, we will look at 3 common expansions. By expanding the linear expressions as discussed earlier, the results can be simplified as shown. Let's look at how to use these results using some examples. For the first example, it is in the form of a plus b square. By substituting a equals to x, and b equals to 3, the result is x squared, plus 6x, plus 9. For the next example, the square of x plus 2y. It is in the form of a plus b square. By substituting a equals to x, and b equals to 2y, the result is x squared, plus 4xy, plus 4y squared. The next example is in the form of a minus b squared. A is equals to s, and b is equals to 2, and not negative 2. The negative sign has been accounted for. By substituting a equals to s, and b equals to 2. The result is s squared, minus 4s, plus 4. For the next example, negative y plus 4 squared, it can be rearranged to 4 minus y, to be in the form of a minus b squared. By substituting a equals to 4, and b equals to y. The result is 16, minus 8y, plus y squared. The next example is in the form of a plus b, multiplied by a minus b. By substituting a equals to x and b equals to 5, the result is x squared minus 25. For the last example, the terms in the second linear expression has to be rearranged to d, plus negative y. By substituting a equals to negative y, and b equals to d, the result is y squared minus d squared. For each of the examples discussed, we have to first identify which form the expansion is in, then identify the term a and b, and substituting them into the result.